So let me get your name first.
Okay, my name is Hassan Basajic,
Okay.
and I work with the Long-Term Ecological Research Project here in the McMurdo Dry Valleys.
And can you tell me about this station here?
Yeah, we're here at Taylor Glacier Met Station. This is an automatic weather station, and we're recording a bunch of different weather variables. Starting from...
Okay, tell me your name again.
I'm Hassan Basajic, and I work with the Long-Term Ecological Research Project here in the McMurdo Dry Valleys. And we're at the Taylor Glacier Met Station. And this is an automatic weather station where we're recording a bunch of different weather variables. And just to run through the different things that we're measuring here year-round, we're measuring wind speed and direction up there on the top left. As you move toward the right, there's the little sensor, the little coupled sensor is air temperature, and that's at about 3 meters. Relative humidity.
Why is that at 3 meters?
The next sensor, well, it's nominally at 3 meters. It's probably at about 2.5 right now. And
that's what the pressure is.
Yeah, so this guy right above me is the just the air temperature, and then relative humidity is the next sensor that has a longer top to it. And then moving out to the right, we're measuring the amount of radiation or light. So that's shortwave radiation, and we're measuring, there's two sensors there. There's an upward facing one that's measuring incoming directly from the sun, and then there's what's being reflected off the surface, and that's the downward pointing one. And so from that we could get an idea of what the albedo is, and whether it's sunny or cloudy throughout the year. Moving downward, we collect temperature and relative humidity again in the back here at 1 meter, and that gives us an idea of how they differ. Most of the time it's much windier up higher. There can be differences in temperature as well as you move upward away from the ice surface.
Because the ice is letting off cold.
Yeah, so during the summertime it'll be much warmer down low, and during the winter oftentimes it'll be a cool pool of air down lower, so you could get to these differentials, and by monitoring at 2 different heights we could get more at the energy balance to see what's going on along the glacier. And so this data that we collect here keeps us, we can monitor long-term climate. We know what's going on year-round, so it supports all the other science that's going on here. And then we also, cryoconite right now. Cryoconites are these holes in the ice that when sediment lands on it, it melts into, there's preferential melt around that sediment, and the sediment will eventually melt down into the ice surface. And then once it's there, it actually, there's some biological things that happen in there, some geochemical things, and that's what Liz is studying with that sediment. So you have this closed environment, and through different cycles of the year there's often water, liquid water in there, airspace at the head there, and then an actual lid that was frozen over. So many of these are isolated for 5, 6, 7 years, and so there's geochemical things going on there, and that affects the water chemistry.
Wow, like life is in there.
Exactly, yeah. And so yeah, there's cyanobacteria, bacteria, and tons of other little beasties that Liz can tell you about.
So why here, and why does the LTR need this information?
Well, so we're in a polar desert right now, and so it's really cold. Not necessarily today, but most of the year it's really cold and it's really dry. So for life to exist here, it's very limited. And so one of the key components that it's limited is in water. And so understanding how water moves through the system, where it comes from, how much of it, and when is it available is really important to us. So one of the things that we do here on the glacier, the glaciers are the main source of water for this area. Precipitation, we do get snow, but it's a very small amount. On the order near the coast, it's around 10 centimeters of water equivalent a year. Up here, it's much lower. It's around 2 centimeters of water equivalent. So it's a very small amount, and that's the average. Some years it's a little more, some years it's a little less. So understanding how much ice is melting is really important to us. And so this weather station gives us data so that we could model how much melt is actually occurring. And that's part of Matt's work that he's working on right now, is he's used this station and modeled melt throughout the year. And from that, he's going to expand and then try to monitor or try to model the rest of the glaciers in the whole valley to get an idea of how much water is being contributed into the system.
How does this station tell you how much melt is happening? I mean, it's telling you temperature, relative humidity, wind speed, direction.
Right, so it's modeled melt based on the surface energy balance. And the surface energy balance is made up of several different components. It's made up of incoming shortwave radiation, what's being reflected, which gives you in sum the albedo of the surface. It's the long wave radiation, and in addition, there's two flux components that are dependent on the wind speeds, and those are temperature and there's sensible heat and latent heat are the two variables there. And then there's precipitation going in, and when that's all said and done, if you have a surplus of energy, that can go into ablation, which can be sublimation or melt, actual melt, and that's what we're interested in, is the actual melt.
What's the difference between those two kinds of temperatures that you were mentioning?
Well, okay, there's sensible and latent
sensible.
heat. Yeah, so one is based on the vapor pressure or relative humidity.
Oh, okay.
And the other is based on, is it temperature? That's something that Matt can talk in great detail on it as he's tweaking that model. So so we've got data here now for about 15 years. So it's considered a long-term data set. Most projects down here, or a lot of the projects down here, are 2 to 3 years. With the LTER, it's based on long-term and looking at those long-term climate patterns and seeing how the ecosystem responds. So we're really fortunate.
This station has been here for 15 years.
Yeah,
or something.
in some incarnation of it. Yeah,
Wow.
and approximately this location. It's been moving down very slowly, but the original location would be probably about 50 meters up from us right now.
So has there been a lot of changes in the past since they've been data? Or have you seen
like as far as so for air temperature, there's been a slight cooling trend in the dry valleys for the past 10 years. Right about the start of the LTER, there's been a slight cooling trend, and it's not a very large one, but it is subtle. There's warm years and cool years, and in 2001 there was what we call the big melt year, which there was a lot of water. It was a super warm December and January, and a lot of water was generated. And that kind of changed the whole system. There was an increase. It was coupled with a large wind event the next season, and so there was that increased the melt, and it's kind of sent a pulse throughout the system. Where if you have more sediment on the glaciers, which was exposed by the big melt and driven by that wind event, then there's more melt. So,
right.
And since that time, it'll be interesting to see what happens over the next years, whether that cooling trend continues or not. So. Yeah, and precipitation is you have big years and small years. There's not really a trend in precipitation at all.
Does this tell you anything about global climate, or does this then get fed into more of a global climate model, or how?
Yeah, so this is a very unique spot in Antarctica, and we're looking at, our project looks at the different dry valleys. Our main focus is in here on the Taylor, but there's 3 valleys that we look at the temperature record in, and it's a very unique area, even compared to the whole continent. There are similar trends going on